In the last video, we saw how to deploy a Spring Boot application inside the Kubernetes cluster. However, if you notice, we had done that using some command line arguments. We did not leverage the complete flexibility of the platform. So we wanted to create a YAML file in order to deploy our applications, deployments, so create services, and then upgrade applications. In this video, we will see how we can use a YAML file to deploy our application, both in terms of creating deployment objects and creating service objects. Also, we are going to use a tool which will create our YAML automatically. Let's get started.
Press the bell icon on the YouTube app and never miss any update from Tech Primers.
So if you had seen the last video, this is the GitHub page which I had created with all the commands which we ran as a part of the video. So you can use it and try it out in your Google Cloud account. So I'll be using the Kubernetes engine inside Google Cloud platform. So same way I destroyed my cluster after I showed the demo, and now I'm going to rebuild the cluster. So that way I'm not charged for my compute which I created. So I'll give the same name which I gave in the last video, right? Tech Primers cluster 1. I'll create 3 node cluster and hit the create option. This will in the background create 3 different nodes in a Kubernetes cluster, and it is going to give that specifically for our account. Meanwhile, if you look at the architecture, what we did, we uploaded the Docker image after creating the Docker image out of that Spring Boot application into a container registry. So some of you had requested me to make that particular registry public, so I'll do that now, so that you can pull the image and then try out what I am doing now. Let me go to the container registry images. Here I can see the visibility. Let me do I'll do settings. I'll make it public. So I have made my repository public, so you can go and take my images. These two are like sample images. I have been trying out different samples to deploy into different clusters or some other examples. So I have made the image public, so you can use the same image which I'm going to show in this particular video. Parallelly, while the cluster is getting created, I'm going to open the Cloud Shell. So Cloud Shell is a terminal which I'm going to use in order to perform my kubectl commands inside the cluster. So I'm not going to install gcloud in my local machine and then have the kubectl installed in my local machine. I'm going to use the Cloud Shell, which gives me a temporary space. So if you are not aware about Cloud Shell is a temporary space provided by Google Cloud Platform so that you can perform some compute on your login. So this is where our projects are. So these are the different examples which you would have seen. So the Spring Boot lazy init example is what we saw. So let's go into the same project. So if you have not seen the previous video, I would suggest go and take a look at it, because this particular video is based on the context of what we did in the previous video. So I'll put the link for that particular video in the right top corner, or you can take a look at it from the description below. So let's do a clear. If I do lslrt, these are the different packages. So we already have the Docker images built, and it is already inside the container registry. So I'm not going to rebuild the whole project to create a new Docker image. Instead, I'm reusing the same image. The only difference is I'm going to create a YAML file. So I'll be showing how you can deploy objects and services inside the cluster using a YAML file, so that you can use it as a part of your continuous integration and continuous delivery platform. So it looks like the cluster is created. I got a notification, so let me go there. Kubernetes engine. Yeah, so my cluster is up. There are 3 nodes in the cluster. If you're not sure about the Kubernetes architecture, do check out my video on the Kubernetes architecture. Now, in order to deploy our application, so for example here, these are 3 different objects or instances. So in Kubernetes world, deployments are called objects, services are called objects as well. So every piece of information running inside the cluster is called object. So the green boxes are all deployments where our code will be running. So these green boxes are different pods which could be running inside different nodes. The orange one is the service object which we have created so that we can use the service object to connect to the deployment objects. So one of the viewer had asked me, why do we need a service? There is no option for us to skip the service, because in Kubernetes, if you want to connect to a deployment, you will have to create a service. So there is no other option for us to skip the service or directly connect to the deployment. You have to use the service to connect to the deployments. Now let's go and create the YAML. So I found out a tool created by Brandon Potter. So he has created a YAML generation script. Basically, this is the UI where you enter some details and the YAML gets generated out of the box, which is pretty good because most of the time the YAML file gets messed up due to space issues. So this kind of YAML generation is pretty helpful when you're working with deployments and when you want to have YAMLs created out of the box very quickly. So we are going to provide the Docker image name here. In order to do that, we need to get the Docker URL. Let's get the Docker image URL, which we have. Here we have to replace the dollar Google Cloud project. In my case, the project ID is this Fleet Resolver 23701. So you guys can use the same image. What I will do is I will put the steps whatever we perform today into a new readme file, or I will link it into the existing one so that you can take a look at it. So I'll in fact append this into the same readme file so that you can try it out. So this is the image. So this is the URL of our image. And if you notice in the right side, the YAML is already created. Like whenever we type stuff, it's getting created on the fly. So by default, if you see, it has picked up the name as Spring Boot application, Spring Boot example. The container command, if you have any container specific command, you can provide it. For example, if I start typing, it automatically adds the command section, but I don't want to add anything. Same with the arguments. If you want to have any container specific arguments, you can have that here. I'm going to give the deployment name as Spring Boot example. By default, it is the same name. Even the app label name is same. So I'm not going to change anything there. See that this is how you can create a YAML from this particular UI. However, we want to expose some specific ports because our Spring Boot application is running in 8080, right? So I want to add this option called add port, and you can have the container port running. So here the port is 8080, right? So I'll just add one more 80. So my port is 8080. So this will expose my deployment and make my Docker instance run on the port 8080. If you notice what we had done here, we gave the port 8080 as a part of the kubectl run command. Now we are wrapping up all these manual stuff inside this deployment.yaml. So this is how you can create a YAML for deployment. So let's copy this and put it in our Cloud Shell. I'll name my file as deployment.yaml. I'll save it. So this is going to create three different replicas, basically three instances of my application. So let's do gcloud, the same credential path which we need to do, gcloud container cluster. Let's do this. So that way it will log in my particular terminal into the cloud instance. So it says grid credentials, no cluster name. Okay, so I think my cluster name is tech primers cluster 1. I'll just rename it. Yeah, so we are logged into the cluster. Let's give some commands. I'll do a clear first. kubectl get pods. Let's see if there are any pods running. There should be nothing running right now because we don't have any application deployed. Yeah, it says no resource found. Let's see if the service cluster IP is running. kubectl get services. That should already cluster IP. Yeah, the cluster IP is there. So there are no services. There are no pods running. Let's check if there are any deployments running. kubectl get deployment. Nothing is running. So let's go and copy this YAML. So we copied already, I think, right? So we copied the deploy.yaml in this particular folder, but you can have it outside the target folder. Right now I think I'm in the target folder, so I pasted it there. That should be okay. In order to deploy this particular YAML, in order to create a deployment object using this particular YAML, you need to give the command kubectl apply -f and the path of the YAML file. So in our case, it's called deployment.yaml. So previously we used to run kubectl run spring boot, and then we provided an image, and then we provided a port. Now we don't have to do that. You can do a kubectl create and provide a deploy.yaml, and then you can do a apply, or you can by default use the apply. So apply will do either create or update. Create will do only create. So let's hit the enter option and see if the deployment is getting created. So Kubernetes now says that Spring Boot example got created. Now in order to check it, we'll do kubectl get deployment. This should show us all the running deployments. So we have 3 instances of Spring Boot example running. Let's look at kubectl get pods. This should show all the 3 pods which are running in the cluster. So we have the 3 pods. Now we can do kubectl get services. There should be no services running, right? Yeah, there's only cluster IP which is running. Now how do we connect to this particular um, instance, or how do we connect to these instances? There are 3, right? So we need to connect to these instances to get the response back or hit that particular REST endpoint which we have exposed from that service or the deployment. How to do it? We need to create a service. In order to do the service, last time what we did a expose deployment and then we created a load balancer service. However, now we need to create something called as a service object. So let's try doing it. So in the YAML creator created by Brandon, there is this option called expose service port. The moment you click on expose service port, notice that a new section pops up in the same YAML. There is one good thing about YAML: you can have multiple applications into the same YAML. So that way, this particular part of the YAML corresponds to a different object and the second part corresponds to a different object. The way Kubernetes parses this YAML file, it knows that this is a separate object and this is a separate object. So in our case, we are going to create 2 different files, but you can also create a single file with hyphen hyphen as the separation point, and you can use it for deploying deployments and services together. So here what it is it saying? So it's automatically adding something called as a service, and it gave the name of this particular service as Spring Boot example service, labels also as Spring Boot example service. Also notice that it created something called as a selector and the app, and that is how the service identifies what are the names of the pods which are running. So if you look at it, there is an option called as app label here. The moment I change the app label to, for example, demo, automatically if you see in the right side, this particular option got changed to demo and this particular option got changed to demo. Basically this is how a tag works. So if you had remembered what I had mentioned in the architecture diagram, if you go back to the older one, see, this is the one, right? So we had something called as tags, and using the tags, the app one is identified by the service here. So this is the deployment, this is the service, and the service connects to the deployment using the tag, and that's what we are doing here. So our tag name is called demo. In this case, you can provide any tag name. I'm just going to remove it. By default, it's going to add my application name as the tag name, so let it use the same, right? And you can override the service name by providing the service name here. I'm not going to use the hyphen service one, so I'm going to use as the same name Spring Boot example. And notice that there is something called as service type. So what kind of service we are going to create? Already there is a cluster IP running, right? So in the cluster, I don't want to create it. So see that there's already a cluster IP running. I don't want to create it. Let's create a load balancer, because load balancer is the one which will create abstraction over our deployment. So whatever deployments we deployed, these 3 deployments, we need to have an abstraction so that when we connect to this particular service, it automatically routes our requests to whichever service is free. So that's what we are doing here. Let me come back to the YAML. Yep, so we are done. So this is our service definition. So if you see, the ports exposed are 80 to 8080, but we need 8080, right? So let me go and change it, because my Spring Boot application is running in 8080, right? And in order to see the logs inside a cluster or a pod, you can just do kubectl get logs and give the pod name. So the pod name is here, right? When we did a get pods, we got the pod name. So let me copy it and paste it. So kubectl logs and then the pod name. This will give me the log name. So notice that this guy is saying that it is trying to pull the image, but it is not. So let me do a cube. So looks like there's a problem while pulling the image, right? So because the log says error from the server container Spring Boot application in pod is trying and failing to pull the image. So let's see what happened in the deployment. .yaml. Let's open that file. So what's happening? It said gcr.io slash fleet resolver slash spring boot example hyphen v1. So this is exactly the same name we gave, right? So let's go to the container registry and then see what is happening. Let's go to images. So let me go here. I'll just copy this, right, and let me paste it. So this is exactly the same, right? 237016. So let's check this in the 23701. Okay, there is a typo there. So we have put 23701. Okay. So this is how you can debug your logs from the cluster. So unfortunately, I gave the wrong cloud ID. I didn't do it intentionally, but unfortunately that's what happened. So let's try reapplying and then see if it works, right? Because now we know that we did a mistake. And if you notice, Kubernetes now says that it is saying configured. Instead of saying created, it says configured. Let's now try doing the get pods and let's see if the status is good. Yep, look at that older one, right? So there is a pod which is getting terminated and the others are getting created on the fly. So we can just do again. We should see only 3 running pods. Yeah, they're good. Now if I do a kubectl logs and then if I give the pod's name, see that the pod names are all dynamic, right? So the old pod names are different. These are the old pod names. The new pod names are completely different. So that's why you need to create a service in order to connect to these pods. See, this is the log statement, and let's look for the port number. Yeah, the port number is 8080. That's why we came here, right? So the port number is 8080 and we are good. So this is the service definition. So we have created a load balancer YAML for the service, and let's create the service. Right now there is no service, right? kubectl get services should show only the cluster IP and not the load balancer. Let's create that. I'll create the vi service.yaml. So this is my service definition. So let me close it. Okay. Oh, I think I gave the wrong name. I should have given .yaml. Yep. So this is what we are doing here. So we are saying link Spring Boot example with the service which you are creating as a load balancer. Same way you can do the kubectl apply hyphen f and say service.yaml. So let's see what happens. Let's do kubectl get services. This should create a new service. So we have a service created. It's called Spring Boot example and it's of type load balancer. And there is a cluster IP, there is an external IP which is pending right now. Once the external IP is provided to us, we will be using the external IP and hitting our endpoints, right? In case of so someone was asking me, why do we need an external IP? How do I make it load balance, right? You can use a DNS to create it. I'll not show the DNS part in this particular video, but we'll see. I need to explore in the GCP how can I create a DNS. I have tried the DNS part before, but it works outside the GCP platform, but I want to try it out in the GCP platform before showing it as a demo. So I'll try that in the next video. So for this video, let's have our agenda simple on how to create the YAML and use the YAML to create our deployment objects. Look at the latest response. We have the external IP. Let's use it and then say 8080. This should hit our deployments. See that it's directly hitting. There's a REST endpoint called lazy and it is returning hello YouTube. So it works, right? So let me refresh it. Yep, it goes to different instances. Now it's all like not going down, right? So that's what is happening. Let me go back to my, I can just do a kubectl get pods to show you get deployments basically. So I can do a kubectl get deployment and see how many instances of my deployments are running. See, there are 3 and 3 are available. If one goes down, it will show up here and the controller in the Kubernetes cluster will try to create a new pod whenever it requires it. Now, how do we apply new changes, right? So in order to apply new changes, you can do the same kubectl apply. In order to do that, let's try creating our new image. All right, that's what we wanted. We don't want to reuse the existing image. Instead, what I will do is I'll go to my source code and I want to change the hello YouTube to hello tech primers, right? I don't want to see that same message, but now I want to use new message so that I can show you guys how my changes are applied in the cluster. So let's change this to tech primers. Let me go back. I'll do a maven clean install. So this is going to clear my target folder. So actually our deployment.yaml and the service.yamls were in the target, but that's fine. We can use it from here, right? Because we are using the same. I can in fact show you how we can update it together. So let me copy it and I'll in fact paste it in the root so that we can use it. So the build is happening. Let's wait for the build to complete, and we will create a cube.yaml, right? So which has both deployment and service together in the same YAML definition, and we will use it. So the build is successful. Let's create the cube YAML here and then keep it before we lose it. I'll just keep it here. That's it. Now, how do we build the image, right? In the last video you would have seen, I showed a example of how you can run image using the Gib Maven plugin created by Google. So I'm going to use the same, but in this case I'm going to create a new version called v2, right? Because we need to deploy a new version of the image because we have a new version of the product. So I'll do the same. I'll do a Maven build with that particular plugin, and I'm going to upload to my registry with a new version. So let's go and check in the registry. Once this gets uploaded, I'll go and check if it is good, right? So let me go to the container registry. Right now if you see here, there is only one version. If I refresh, I should see the second version if it has got uploaded. Let's check if it is okay. Now it's pushing the image, right? So it's getting built. Let it push and then I'll go back and see once the images are pushed. So the image is pushed now. Let me go back and refresh. I should see a new version. So you guys can use the same, right? So if you want to use the version 2, use v2. If you want to use the version 1, use v1. Now I need to modify my cube YAML, right? So let me go to cube YAML and I need to change my v1 to v2. So I have done that. I have changed my v1 to v2. Let me save it. In order to apply my changes into the cluster, I can use the same kubectl apply -f, and then in this case I'll use the cube YAML. If you're creating new instances, you can do a create, but if you want to generally update stuff, then you can do an update apply. So see here, deployment got configured and the service got changed. That's what it says. Kubectl get pods, kubectl get deployment, and see that the age is 21 seconds, so which is now, right? So it just happened now. Kubectl get services should show me the services. Yeah, see that the service got deployed, but nothing would have changed because the service did not change, right? So that's what it said here, right? The service did not change. It says unchanged because we did not change anything with the service definition. However, we changed something with the image, right? So the service is undisrupted. Now if I hit the same lazy endpoint, this should return me tech primers, right? Yeah, it returned tech primers. So that's how you can do a upgrade, but the only downside is we did not deploy any strategy, right? As a part of this particular upgrade, we just did a plain deployment. We did not apply any type of strategy, for example blue green deployment or rolling updates. We can take a look at that. If you guys are interested, in the next video I'll show you how you can do rolling update inside Kubernetes, how it deploys one by one in each of these replicas. Basically we had 3 replicas, right? It deploys one by one and then we can see how Kubernetes is intelligent enough to do that automatically, right? So if you guys are interested, let me know in the comment section below. I'll go ahead and do a video on that in the next video on Kubernetes. So I'll just summarize what we did as a part of this particular video. We first initially created a cluster and we tried to create different deployment objects using a YAML file, and we did it using kubectl apply command. And we also created a service using the same command but with a different YAML definition, which we created out of the YAML creator, which we have here. Once we created, we wanted to deploy a new code into the deployment. So what we did is we rebuilt our image by modifying some changes in the source code, and then we rebuilt and then uploaded it into the Google Container Registry, and we updated the YAML file using the same kube apply command, and only the deployments got changed and the service did not get changed because there was no change in the YAML definition. So this is how you can use Kubernetes to deploy applications into Kubernetes and upgrade your application whenever you require. So the good part about Kubernetes is most of the steps you perform are all based on command line interfaces. So whatever I showed you, we perform lots of different commands, right? I'll use these commands and then I'll add that into the README so that you can take a look at it. Everything is based on commands, so you can automatically add these into your continuous integration and continuous deployment pipelines so that you can automate your deployment end to end. I hope you got something out of this particular video. Do try out Kubernetes deployments in a Google Cloud platform, which is completely free. I'm using the same. Let me know what do you feel, what are the issues you guys are facing. As always, if you like the video, go ahead and like it. If you haven't subscribed to the channel, go ahead and subscribe to it. Meet you again in the next video. Thank you very much.